So my name is Stephen, whatever you want to call it. So yeah, I work at Wolt. So maybe a quick introduction for the people that don't know Wolt. We are a tech company with a bit more than 5,000 employees now, and we started as a food delivery company. So kind of like DoorDash or Uber Eats or whatever you want. And we're now a delivery company, so we shifted a bit on that regard. And we are in 23 countries, more than 200 cities, more than 15 million customers. And most importantly, we have many data scientists, and that's the most important part. So to work with them, we are two machine learning engineers, so me, Stefan, and Tim, that is here as well, and we are part of a core machine learning and data engineering team, which is basically in charge of providing services to all the other teams, so to data scientists, but to data analysts as well, and everything, so that they can work and they don't have to focus, on Kubernetes or anything related to that. They can just write some code. So yeah, basically that's what we are. And at Wolt, we have ML. We have ML a bit everywhere, to be honest. So we have supply and demand forecasting, and then we have recommended systems. So on the app, when you open the app, you get some different recommendation based on your preferences. So if you're vegetarian or not, and all the things like that, and that is done with ML. We have one which is very important, which is the delivery time estimation. That's when you order something, then we estimate the time that it's going to, take them to prepare the food, take them to prepare the order, delivery time, drop-off time, all of the things is done with ML as well. And that is a bit more real time than the other ones. And then you have fraud detection and ticket ranking that is helping support when you contact them to know if your issue is like very important and needs to be addressed within seconds, or if it can wait like 1 or 2 minutes, for example, and that also is done with ML. So yeah, and so basically like that talk is on my side. I'm just going to explain on what's the idea of the ML infra and what we want. And then Tim will go a bit more into the details and our implementation and like what glues everything together between Flyte and the rest. So basically what we want is we want tracking and versioning for the models. Then we also want, machine learning pipelines so that we can train model easily with tracking and versioning of different workflows. Model registry as well, model deployment that is made easy and without downtime. Because one of the problems that we had before was that deployment of models was very hard, and everyone was doing their own thing. And then model monitoring, so that means, like software monitoring, like, I don't know, latencies and everything, but also the feedback of your model. So we want to make sure that, the model works as expected. We don't want to be blind, basically. So yeah. And so how we're doing it is, so we have Flyte, as I think you guys know what it is. So we use it, we will use it to train the models. And basically we're moving away from Airflow to Flyte for everything related to machine learning. And then you train your model, then you're pretty happy. And then we make it possible to save everything in MLflow so that, you can track your experiments, track your models. And well, I mean, I think everyone knows MLflow here as well. Then we have some services that we created that are basically making the link between Seldon Core, which is what we use to deploy the models for the models that are deployed in real time, and basically Flyte. So the idea here is like you train your model in Flyte, you push it to MLflow, then you check if the metrics are better, for example, or if you check different things, and then that service is going to check it everything, and then it's going to update everything in Seldon Core without, of course, downtime, but also, making some checks like sending a notification on Slack saying, hey, that worked as expected, or hey, there was a problem during your deployment. And we're like working on improving the service so that, once you push something, you also say, hey, yeah, your model has been deployed, it's better, or it's not better as the previous one, so maybe you should check that. And yeah, basically that's the idea, is like Flyte will be used for everything related to machine learning. And then I think fairly soon we should also use Flyte for models, but that are not real time. So Seldon is here for real time, but Flyte will be there for the models that are not real time. And so, yeah, so that means, I don't know, like the forecasting, for example, that I talked about before. Yeah, and so that's basically what we're building. And so those are like only the cool stuff, you know, the thing that you want to use. But then behind the scene, there's a lot more things. And so that's kind of what it looks like. If I go a bit more into details, so we use Kubernetes, of course, and then we have a specific machine learning cluster where on there we have Flyte, then we have Argo CD, and then we have different Python services. But then we also have the application cluster where you have all the applications of Wolt, but then where you also have Seldon core deployed there because the models are in the application clusters. And then, yeah, basically, like you take the data for the data warehouse. On our side, we use Snowflake for now, but it's more like, yeah, how exactly do you make it easy for data scientists to get the data from Snowflake to Flyte, for example? And then in the future for real time and all the things, we'll have a feature store. We don't have it for now, but yeah, that's basically the idea of, I mean, I guess it's what everyone is building at the moment, is to have, you know, a very specific ML cluster, and then how do you make it talk to the rest? So yeah, basically that's it. You have the ML cluster with Flyte, and then Argo CD, which we use to deploy Flyte. And yeah, no, I think my colleague is going to go for it now.
Thank you, Stephen. Hi, everyone. I'm Tim. Can you hear me, by the way? I don't say. Yes, nice. All right. Yeah, I'm going to talk a little bit about end-to-end integration, but maybe not in the way that people usually talk about it. That is like talking about great modern data stacks and the ML lifecycle and painting a pretty picture. I want to talk about like the nuts and bolts and the nitty-gritty details that you need to have good Git practices, data security, etc., while still enabling data scientists to focus on the stuff that really matters for them, that is producing the best models. So yeah, we have this company internal meme that people spam pictures of Ford Focus around, so I thought I'll echo this here. Next slide, please. So how do we want to enable them to focus? Essentially by removing some of the most common friction points in their workflows. So we want them to enable to really quickly set up new ML repos by using templates and shared resources wherever possible. We also want them to enable to access the data that they need for training their models easy, while at the same time being secure. We don't want everyone to have admin access to our warehouse. That would be easy, but that would not make us GDPR compliant. And on the note of GDPR, this data access needs to be auditable at the end of the day. So I'm going to go into some details there in a moment. And then we would like to keep best practices, best developer practices in terms of Git branching, and generally have everyone sync their work and version control their work, and make that match up with the concept of Flyte domains. So I'm going to go into detail all of those. Next, please. So yes, in terms of making it really easy for people to set up new projects, in the beginning we thought, there's going to be one repository and a lot of different teams have a lot of different workflows in there, but that would be horrible in terms of code review and in terms of the peculiarities or special needs and dependencies for every project. But if everyone is cooking their own repositories anywhere, then we will have a hard time maintaining common ground rules. So what we opted for is that we have a Git template, Flyte template repository, and then we're using GitHub's create a new repo from template feature to basically cookie cut, without cookie cut, new repositories that already share a whole bunch of common tooling and configs. So they will all share the same CI pipelines, just with like the names of the project or whatever automatically read from however they name their repository. And these pipelines are then triggered and do things like creating the project in our Flyte cluster. And then from there on, they handle everything from registering workflows to setting up configs and terraforming permissions for accessing secrets within your specific repository, so that ideally every data science team has the maximum amount of autonomy in their repository. They can do their project there, but everyone adheres to shared protocols. Next slide, please. And yeah, one of the key things that we need people to adhere to is, well, data access rules. So this is why we actually created a Wolt secret manager plugin for Flyte, because we're heavy users of Wolt. And one of the things that we want to enforce across every machine learning project that uses Flyte is that they follow the same role-based access control that we use elsewhere in Wolt. So, and we want to scope this to basically every project domain combination. So if I'm in my project in the development domain, I have an IAM role, I have a Wolt role, and through this Wolt role, I have access to different secrets that I might need. For example, dynamic database secrets in Snowflake, where again, I have my corresponding Snowflake role, which gives me access to specific tables I need. And this is a horrible mess to configure. And for a little while, we've been doing this by hand, and it was bad. So now we're automating all of this. So essentially, data scientists, when they start a new machine learning project, they just have a nice little config file in a domain-specific language that we developed at Wolt for basically making stuff easier by removing us one step further from from Terraform. However, it does make things easier for them, because essentially they can specify a list of buckets, of secret locations, of Snowflake tables and schemas, and then out of the box, within their workflows with the Wolt Secret Manager, they will be able to access the secrets that they need. And we make sure that any access to the warehouse is audited, but also that no one can like escalate from the development domain to prod and delete data there accidentally, or that projects can read data from another, and vice versa. So yes, this is helping us a lot. Next slide, please. And lastly, we're big fans of good Git practices. So we thought we have this notion of the domains and that things are being promoted along the domains in Flyte, and we really like that. And we thought we matched that up with a branching policy, and kind of set this a little bit in stone with how we structure the CI pipelines. So essentially, when you're a data scientist and you're in your machine learning project repository, on any feature branch, like you can do within the bounds of your permissions, you can do whatever you want. You can experiment away, you can fast register, you can start workflows, but you're isolated in the dev environment and scoped to the permissions you have in the development domain. And then when you're ready for integration testing, you can promote this to staging by opening a pull request to staging and have a classic code review. And then you don't need to do anything. Then the CI pipeline takes care of registering your workflows to staging domain. And actually there we safeguarded, like you cannot manually register there, and you cannot manually fast register there. It has to go through a pull request, so that people cannot like accidentally, skip a stage there. And then lastly, with a PR into production, after you've integration tested everything to work together with MLflow and Seldon and the other services, then things can get properly trained and deployed. And this seems like a lot of work, but because we want to automate everything around, we hope that for the data scientists themselves, it just feels like the normal everyday Git workflow, because things like registering stuff, rebuilding the images, they just happen automatically in the background. So yeah, this is the ML funnel that we liked, that we want to build with matching the features to the domains. Next slide, please. So to wrap this up, I think this is our aim. I think everyone has seen this picture in one way or the other. It's been talked a lot about, but I think there's truth in it. There are all these components. I haven't really talked about these components, but what I wanted to talk about is like let's say the threads that pull all these things together behind the scenes. That's what we try to configure in such a way that data scientists can really focus only in the ML code and write that into neat Flyte workflows. Thank you very much. Yeah, any questions?
I do. Go for it.
Yes,
Sure.
Go ahead.
Sure. So when I'm curious about the skill set of your data scientists. Like, were they familiar with just using Get in the beginning? Do they write their own workflows when they're typically trying to productionize something? Is that something they do with their own two hands? Are they working with an ML engineer? Just what's the persona look like for your folks? Because it sounds like it's a little different from the folks that we work with at Lyft.
Do you want to start, Stephen? You know them longer.
Yeah. So our data scientists are usually very curious, and they are usually not afraid to get their hands dirty. So that means it can mean like everything. So yeah, Git checkout, writing Docker images, writing fast API once needed. So that's what we used to do before Selden. They would write their own APIs and their own routes, and it's everything. So yeah, they're usually very curious. And I mean, we have a lot of different teams at Wolt. So the core teams where we provide services for others. So, you might need to do a Git checkout, but then behind the scene, like a lot of things are happening automatically as well. So we try to also reduce the complexity there, but they're usually not afraid to do things like that. Yeah.
But just the whole idea that if you do a pull request to the new branch, you're going to get a different set of permissions, that you can get that idea across to them and they go, oh, that's a good idea.
Yeah.
Yes.
That's cool. And then a little bit of just a question on how you got here. Did you guys sort of make this big strategic decision to go K8s before you chose this particular tool set, or did the tool set kind of lead you into K8s?
K8s was a constant long before. Yeah.
Okay, so somebody had decided like we're going to try to make K8s be our core backend infrastructure and that.
Yeah, I mean, it has been, it's everywhere at Wolt. So like our whole stack is on it. So
cool. And then I find, at least my last question, like what are you getting out of Flyte that you were not getting out of Airflow? Because you could have built a lot of this stuff on top of Airflow yourselves, right? You have the skills to do that. Why didn't you just extend Airflow? There's a common pattern we see.
Yeah, I mean, there are a lot of things that we don't like about Airflow, basically. But let me think a bit. But it's like also like the different domains that you have in Flyte already in the first place, which is good. So that's the first thing, and then all the versioning, all the caching, also that you have. You don't really need to think about it. Usually you have it yourself. So those are like key decisions in the first place that we have. Yeah.
So Flyte's a very opinionated system about those things, and you kind of agreed with those opinions. Is that a high level to put it? Okay.
I mean, on my side, yes, maybe Tim.
I'm sure you didn't agree with all of them, but at least the big ones.
Yes.
Yeah, I think the benefits, there's so many benefits, I don't even know where to start. Just that, I mean, Airflow is not Kubernetes native. Like, yeah, you can force it to work there, but it wasn't meant to work there. And just the fact that every task is a pod, that it's containerized separately, I mean, and adds to the fact that you can parallelize within tasks, adds to the fact that you can have dynamic tasks, which I think is not possible in Airflow. Like, you need to know the amount of steps beforehand. This just seemed next level. Like, I personally really love Argo workflows. That to me is like the king of workflow executors, but I think Flyte takes the best of that and makes it usable from someone who prefers to write workflows in Python in a really, really neat way. So was an obvious choice, I think.
Yeah, and also it's language agnostic, so you don't have to use Python, for example, and that's a big thing. Yeah. Like, it's the same for Selden. You don't have to use Python. You can if you want to, And that's a big thing because at the moment, most of the things are done in Python, but we probably will have some models in Java and everything. So that's also something else.
Yeah, if there was the fourth language you would recommend for an SDK, what would that be? I mean, right now we've got Scala and Java, thanks to the Spotify folks, and then we did the Python one. And anybody clamoring for R or TypeScript or no?
If I had to choose, I would choose R, I guess, because we have seen some folks who've been interested in it, but some other set of data scientists, and I think they don't get enough love from the data science community. So, and we love everybody.
How much R code have you written?
So if there are any R folks listening to this talk, join our community. We love you guys.
I'd love to have somebody like wants to bake the R SDK. That'd be super fun.
Yeah, I think so. And so we actually went to a point of almost generating the R protobuf definitions. The question over here is to do like R completely from scratch, or use the RPy kind of bindings, or use our Go bindings or whatever. But yeah, we are open. If you guys have ideas, if you have needs, please join the community and directly ping me, and we would love to see how to get this rolling. I had one question. So it's great to see how the domains are being used. And Stephen, you mentioned things about domains. So at Lyft, we did have these domains and exactly similar sort of stuff where you cannot access roles across these domains. Like to a domain, the roles are tied. And you can do it. I don't know if you guys are planning to do it at some point. You can separate the Kubernetes clusters across these domains if you want, or whatever, right? That way the blast radius is kind of like almost made zero because the fabrics themselves are separated. But
yeah, we're about to do that.
Yeah. So the one problem that caused in the user's journey was, and this is where fast register was added, that every time they created a PR, they had to build the containers, right? And that takes some time, specifically because the caches and so on are not really like local. So it might, and we created fast register for that. But do you think, has that been an impediment? Are folks not happy about it? And we would love to understand, how do you really resolve this problem and still keep the MLOps way of doing things? We're kind of like trailblazing MLOps here, right? Like we're doing something different, but that causes pain. And how do we really solve that? We would love to know if you guys have heard about it or thought about it.
About fast registering particular, or?
Yeah, just in general, maybe fast register is one way
Yeah.
to achieve a solution, or maybe you build Docker containers locally and push it. Like some people do that.
Yeah.
I think Freenome team does that, and some other people. Like there are different things that people are doing. And what do you think you like or you don't like, and what works, what doesn't work?
So maybe I can answer. When I tried out Flyte for the first time a couple of months ago, it took me like, half an hour or so, and then I was like, damn, there must be an easier way. I cannot like rebuild this all the time. There's no like change to the dependencies. So then we discovered fast register quite fast. Setting it up was a bit hard because I think we just started when you were introducing new changes to PyFlyte, and there was this precursor to Flyte CTL. What was it called? Flyte CLI, and there was like a stage where there were different ways to do it, and eventually, or fairly quickly, we found one and we loved it. So it's definitely an integral part on the development domain for people to iterate really fast. So I think one way to iterate really fast for them is just to run the workflows locally, which is also great. That's a great benefit of Flyte, that at least if you have Python workflows, you can just run them like local Python code. And then the next one, if they want to try it on the cluster with more compute power, fast registers is definitely super helpful. But then as we move up into the funnel, we considered it safer to then use the CI builds. And because we assume when you're in staging and then in production, there's not so many code changes anymore. You're basically just executing the thing over and over again.
Yeah, I agree. I think probably using fast register in production is not a good idea. Somebody may just delete the piece of code somewhere. And with fast register, would you like? I think we've had this for a bit, and we've talked about this back and forth. We are not a big fan of Pickle as a medium to transfer code, but fast register essentially, is your entire code zipped up. Do you think it makes sense to actually add that kind of an API to Flyte itself, like admin, so that you can just upload and proxy it to like a code sandbox repository, not really a repository, but a blob store bucket or something? Or do you think it's okay to have the users have the permissions to write to GCS or S3? I don't know. Do you guys run it on Google or AWS?
We run it on S3. Okay. And no, that's fine. I think it would be super helpful. Like one thing that would be super helpful is if fast register figures out from your Git state which workflow files have actually changed and only registers them.
Rsyncing, that's a good idea. Let's actually, we'd love to pull your brain on this, and like we can. I think there are ways to move ahead and move faster in this direction and make it cleaner. But no other questions from me. Anybody else?
Yeah, I have a quick question. Sorry, Jason. Eating into your time here. But a quick question just about the process that your data science teams have when coming up with like a brand new model, like application. Is the whole like feasibility study, data exploration thing done outside of this infrastructure or within it?
It depends.
Okay, cool. I'm just curious because.
But for now, it's mostly outside, I'd say. I'd say it's usually outside for now, and we'll see how it moves, how it evolves basically. Because a lot of things that were annoying for us was like the whole access to Snowflake and everything, and now that we made it easier, we'll see what happens basically.
I see. Cool. Thanks.
Fantastic. Thank you, guys. You've almost created a reference architecture, and it's interesting. Lyft, Gojek, you, Toyota, all it's the same architecture now. It's awesome to see that.
Reinventing the wheel.
Exactly.
no, that's great. That confirms that we were onto something. Thank you.
Yeah. All right. Awesome. Maybe there is a startup on top of this.